Welcome to PWGC's Environmental Echo. If you have been keeping up with the news, there has been a lot of talk regarding the treatment of wastewater on Long Island and how to pay for it. Most recently, New York State Governor Kathy Hochul announced a $2.25 million state grant for Nassau and Suffolk counties to promote the replacement of aging septic systems with innovative alternative wastewater treatment systems that drastically reduce nitrogen loading. At the same time, news also broke that the Internal Revenue Service will no longer count the grants for these systems as income, which should boost interest in the installation of these cutting-edge residential wastewater treatment applications. Given these current events, we wanted to revisit our wastewater episode to examine how these changes will affect our region. We hope you enjoy the episode.
Welcome to the PW Grocer Environmental Echo podcast. I'm Paul Boyce, I'm the President and CEO. And with me today, I have Bryan Grogan, one of our vice presidents in the engineering group, and I also have our marketing director, Nick Anastasi. Today, you'll be listening to our third part of our three-part series on water quality issues as they relate to Long Island. We'll be covering topics today on wastewater that include nitrogen and wastewater impacts on the groundwater and surface water bodies here on Long Island, as well as treatment technologies. And we're also going to be covering, what's next for Long Island as far as wastewater management goes. And in the meantime, if you guys, before we get started, if there's any questions or concerns or issues you may have regarding this podcast, we're always happy to reach out to folks, but you got to reach out to us first, and you can do that through our website, which is pwgrocer.com/podcast, or through our social media outlets. But today, as I said, I got Bryan and Nick with me today, and we're looking forward to get started on this interesting topic of wastewater, many people refer to as doo-doo voodoo.
Love it.
How fun can that topic be, right?
Oh, it's going to be a blast.
We can't get into any trouble, right? So, Bryan, let's literally dive right into this topic, shall we? All right? And let's try to stay as clean as we can for our listeners. But, we mentioned nitrogen, Big, hot topic here in Long Island. It's been that way for a while, and it's probably going to be that way also for a while, It took a long time for us to get into this position, and it's going to take, oh boy, a long time to get out. So, as far as wastewater and nitrogen go, what do you think is the most prevalent or the biggest problem we're facing right now?
Right now, it's basically lack of, I'll say, proper treatment. We as a whole in Suffolk County, we're kind of, I'll say, stuck in the Stone Age a little bit. The old rules were you basically put it into a system, whether it had been a cesspool up until the late mid-'70s, and then you switched over to a septic tank at a cesspool. If you ask most homeowners these days where your septic system is located, they're going to look at you with a blank stare, unless they've ever had to have it pumped out. And even then, if they've pumped it out, you ask them, well, how often did you do it? Well, once every 20 years when it backed up. Well, basically it was the ultimate out of sight, out of mind. You flush the toilet, it goes away, and you never see it or hear from it again. But that waste, ultimately was recharging back into groundwater, which ultimately feeds a lot of our surface water bodies and our drinking water supply. So as you started to develop in the county, you would see these nitrogen levels starting to creep up. And has impacts across the board. Like I said, in surface waters, that's one of the primary causes of, algae blooms and, surface water degradation. And then as well as for the public water supply. I mean, out west in Huntington, I think, years and years ago, they had, development boomed and, you had to locate new well fields and shut all the ones down because of the high nitrogen concentrations.
Oh, man. So just real quick, if you can answer, just for some of our listeners, what's the difference between a cesspool and a septic tank?
So, the basic components, a cesspool was basically old technology. It used to be old block. It was, cylindrical block structures that you made brick by brick and you put them in your backyard. And it did everything. It collected solids, it leached water, that was basically it. If you pumped them down too much, they would collapse on you. So, there was always kind of a safety factor with those. We switched to precast concrete, but it was basically the same kind of situation. It's a 8-foot diameter precast ring, goes in the ground, you bury the top, you never see it again. Septic tank at least gives you some treatment. It basically is, acts to collect the solids. There's a baffle wall in the middle. It kind of settles everything out to the bottom. It allows for anaerobic digestion, so bugs to grow in the absence of oxygen can kind of grow and break down that material. And then the lighter liquids would leach out or leave from the top of that tank through a pipe and go into then what would be considered a leaching pool, which main goal was to recharge that water or that, I'll say, treated effluent into the surface or into the ground. That was really the main kind of crux of it.
So we're saying like the cesspool's the one-stop shop. It handled everything, whereas then we eventually evolved to these septic systems that have a little bit of treatment, as you said.
Correct.
All right. And we're talking about nitrogen, and it's in the wastewater. And not to get too graphic, but where's it coming from?
The main nitrogen is urine, for the cleanest term I could think of. And that's basically, it's in the form of ammonia. So you have to, basically transform the nitrogen or the ammonia through the nitrogen series all the way down to nitrate. And that happens via a biological process. And, you're using natural bacteria, you're feeding it with food, which is the other part of number 2. Access to food for the bugs, and in the presence of either oxygen in an aerobic system or anoxic with no oxygen, you can kind of start that conversion process. There are ways that you can do it chemically, and I think that's some of the more exciting research that places like Stony Brook University are doing now, is finding the bacteria that can kind of short cycle that whole process and kind of skip from ammonia right to nitrate. And it's a matter of, can we do that effectively and not overly costly, so that could work out for us.
So what's, the long-term solution? Where do we go from here? We, as you said, this is, it's been evolving for a long time, and it's going to take a long time for us to remediate this. But, what are the ideas going around right now? How do we address this? I know we've mentioned it in some of our previous podcasts. We've got some political leaders right now that have the will to take this on. What are we doing?
So right now the county had completed in the last couple of years a county-wide sub-watershed management plan. And that focused on, what kind of wastewater technologies we have in the county, all these individual sub-watersheds, what the nitrogen loads were, the calculated nitrogen loads for each of the individual water bodies, and it kind of put forth a plan to rectify it. Now that plan, again, depending upon the area, involves utilizing large-scale municipal sewers, kind of like what we have down in Bergen Point in Babylon, or in villages like Patchogue and Sag Harbor and scattered kind of throughout the county. I think there's 20-something county districts that we have in the county there. But largely, we have, I think, 350,000 unsewered homes in Suffolk County. It's one of the largest, batches of unsewered population. And, right now, the majority of those are on the conventional septic system, septic tank, leaching pool, or even cesspools. And one of the things for those where sewers are not a viable option is these innovative alternative on-site wastewater treatment systems. And these are basically mini sewage treatment plants that go in your backyard. This is something that's relatively new to the county in the last, say, 4 years. It's not new to the world. Again, we were a little behind the times here, but these treatment systems have an ability to treat nitrogen to probably about 85-90% reduction. And we probably should have been embracing the use of these a long time ago. They're not super maintenance heavy. They're relatively easy to install. They look kind of like a septic tank. They all work in a variety of different ways, but basically it's an even swap for one of these units from a septic tank. So that's, I think, going to be the biggest key to fixing this puzzle.
So how much of an improvement on, say, like the nitrogen loading do we get if we switch over from like a typical or standard septic system to one of these IA systems?
So, we say that a typical septic system, a septic tank leaching pool puts out an effluent of around 50 milligrams per liter of nitrogen, all said and done. The IA units, the goal is 19 milligrams per liter, and the majority of these get down to below or right around 10 milligrams per liter.
So you're getting like almost, an 80% reduction in the nitrogen.
Correct.
Using one of these newer systems.
Correct. And there are some that Stony Brook University and the Center for Clean Water Technology are using more, I'll say, natural, systems, these nitrogen-reducing biofilters, or NRB. But these are getting numbers down in the 3 milligram per liter range, which is great for improving water the overall groundwater quality. So it is possible to do this, and you can see it. It's just a matter of how do we implement it, wide scale. Like I said before, I think we had 350,000 unsewered homes, that we need to get to.
Paul, real quick, as we move forward with this discussion, could you just briefly go over how the nitrogen from a wastewater collection system, say a cesspool or a septic tank, gets into the groundwater, and then how that groundwater migrates towards these surface water bodies? I think that's important for our listeners to understand.
Yep. You're talking about fate and transport in the environment here. All right. So we've previously discussed that the soil is porous, right, in some of our earlier podcasts. So once that liquid, that effluent, comes through a septic tank into a leaching pool, it comes in contact with the soil, and it starts to migrate or percolate through the unsaturated zone. So the pores are unsaturated at that point. They're empty. We're now filling them up with this, wastewater effluent or leachate, whatever you want to call it, effluent, I suppose, and it's going to make its way down to the water table, where the pores in that soil are now saturated. All right, so it's going to enter there. It's going to get into the water, and as we've previously discussed, the groundwater is not static. It's moving. There's gradients that cause it to flow from, let's say, high to low. All right, so as it gets into the water table, it's going to then start to move with the groundwater. And as I've mentioned previously, also, nitrogen is fairly conservative once it gets out into the environment. It doesn't like to break down readily.
Right.
Brian went through a whole bunch of processes, how you can do it, and that's involved. That's not typically occurring readily in the environment.
Right.
So once it gets in there, it's usually in there for a little while, and it starts to flow and migrate, and you will start to see that groundwater will flow, as I said, from high to low. So if you looked at Long Island, and you look down the spine of Long Island, like the Long Island Expressway, sort of like the high point in the island, right? It's called the groundwater divide. Sort of, simultaneous or, matches up pretty well with the Long Island Expressway, the LIE. So water north of the LIE flows towards the Sound, generally. Groundwater south of the LIE flows towards
the
bays and the ocean. All right, so depending on where you are, it starts to migrate in that direction. It's got deep recharge. It means it can start to migrate vertically as well as horizontally. But if we just focus on the horizontal aspect, as it migrates to a certain direction and a certain velocity, if it encounters a surface water body, be it a stream, a creek, a lake, a pond, you're in. It's that simple. It's maybe I'm oversimplifying it a little bit, but that's typically how it happens. It goes from your septic tank into the soil, down to the groundwater. It starts to move with the groundwater, and it ends up, in a surface water body where, as we said, nitrogen's a nutrient, and whatever's in there, be it invasive species, plants, bacteria, whatever, is going to start to use that nutrient and start to thrive, and that's when you start to get some real problems with brown tides, the cyanobacteria. The invasive species love it too. It's like a fertilizer.
I just have one follow-up question in that regard, this applies more to Suffolk County than to Nassau County, or areas in the city. But as the population has increased on Long Island, and more of these septic systems were installed, and it's been decades at this point since, as the population has continued to grow, I would assume that the level of nitrogen has steadily increased with these new systems that are talked about, as well as the potential for a large municipal collection and treatment system for Suffolk County. How long will it take as the water moves? I'm assuming from previous discussions, the water moves very slowly. How long, if it was a perfect scenario and there was no more nitrogen being put into the groundwater, how long would it take for that nitrogen to dissipate?
Well, that's a good question, Nick, and we've actually at PW Grosser. But I'll give you, for instance, we were working on some sewering projects, and we were looking at, say, like the Sunrise Highway area on the South Shore of Long Island. And we were just saying, okay, what's the groundwater travel time from, say, Sunrise Highway down to the bays, South Shore? Care to take a guess?
10 years.
No, a little bit longer. About 26 years we were estimating, So somebody that flushed their toilet up by Sunrise Highway goes out to the front yard, you'd expect that nitrogen or that water to reach the bay in maybe 26 years, maybe even longer. All right? So the further inland you get, right, the longer it's going to take to flush out, as you said. So like I said, that divide might be further north, maybe up by the LIE, Southern State, the further north you go. It's just going to take decades and decades longer. So as Bryan said, we're probably 40, 50, 60 years, if he had a magic wand or a magic sewer, and we could just stop all the nitrogen right now today from getting into our groundwater, it's going to take decades for it to get out from, the way we've been, our past practices and the way we've lived our lives.
Understood. So the bays, for argument's sake, on the South Shore are just seeing effluent or nitrogen from depending on your location south of the expressway, from the 80s and 90s.
Yeah. No, and that's, and again, that's why I think we've done, there's been work done to prioritize certain areas, where a lot of these IA systems have been, I'll say, targeted on the coastal, communities, the ones that are right on the water, because, yours has the most, I'll say, significant impact. So that time frame, if you're right on the water, you could be reduced to a matter of minutes before your wastewater's hitting the water.
Right.
And there's no changes to it. At least in 26 years, it has time to go through that nitrogen cycle kind of naturally. But when you're right on it, you might as well have the pipe sticking out the bulkhead.
Right.
Oh, I hope not. Bryan, I do want to ask you one question. What's the septic system is just, as you described it, it's a concrete, static, sort of this dumb thing that just sits there and doesn't do anything other than have water flow through it and settle out stuff. But the IA system, what's the big difference between that and that, big concrete structure?
Yeah, so the IA systems are, from a manufacturing perspective, a lot of them are, fiberglass. There are still some that are concrete. But basically they are treatment plants. They have, in essence, or creating the living conditions for the biological process to happen. It's basically, in a real simplistic view, as my old boss used to tell me, it's bugs and bubbles. You put air in it, you have aerobic bacteria that grow, that are naturally there. They proliferate because it's aerobic. They're getting fed by your wastewater stream, and their sole job is to take that ammonia and convert it. And basically by doing that, you're enhancing that biological process that otherwise would have taken 26 years can be done in, under 24 hours. And that's really the goal of these, is to kind of, keep that growing and kind of go with it. Now, there are downsides, and there are habits that people need to change. You can't, go crazy and do 12 loads of laundry in one day over the weekend, because you kind of flush out bacteria. You can't really wash your paintbrushes out in the sink because you'll turn everything white and kill it. So, there are things that people need to kind of, change with that mindset. But, these systems, like I said, expedite that natural process, greatly. And that's kind of really what the main difference here.
All right. Are there any other issues that, like, say, a homeowner would have to be aware of? You mentioned, typical homeowner may not pump out their system until it backs up on them, which could take, you said 20 years, 9, 10 years or whatever. How frequently do these things require maintenance?
Again, right now, the county in their programs requires that you have a 3-year O&M agreement with a licensed provider from,
O&M?
So an operations and maintenance agreement. So this is basically, you're going to hire somebody like you would, like, for your HVAC system or for your oil burner, that comes in maybe once, maybe twice a year, checks out the system, make sure everything's working, make sure there's no, broken pumps or equipment. And then, they'll take samples, I think, every 3 years and make sure that the system's still working. So far, again, I think once these systems have been kind of upstarted, there's really not a whole lot of maintenance. Some of them are far more simplistic than others. Some are gravity fed and only have what equates to a large fish tank air pump. So if something goes wrong, it's $100 and you get a new air pump. Others have pumps and other mechanical pieces in them that can, break down over time or get clogged with, baby wipes, or the so-called flushable wipes that every wastewater guy in the industry hates. Because they're flushable, just means they get past your toilet, but what they do downstream is, ridiculous. And, maybe you'll change your mind after you pay a guy to come and unclog them from your pump 3 times in a row. You might stop doing it. But yeah, I mean, that's, these things are pretty robust. They're, it is a little bit of a different mindset. You do have to occasionally pump them, because some of the sludge does build up as kind of a byproduct of that natural process, and that needs to get removed every, say, 3 to 5 years. But it's going to depend on your usage, how many people are in your house. Is it 2 people or is it a home of 6 or 7? And you'll have different water usage, and things will change there.
So, and I'm not trying to knock these things, though. The one complaint people, we've worked with these systems, we work with the homeowners. A few of them have mentioned, what happens when my lights go out? I lose power. I can't blow the bubbles. Is there a bypass? What happens? Can they still use the sink, the toilet, the shower?
Yeah. So I mean,
obviously they're not doing dishes or laundry when the power's out.
Yeah, it really depends on how your system is set up. Like I said, some of the IA units themselves are gravity in, gravity out. So basically, it's kind of your traditional septic tank. You flush it, water flows in by gravity because the pipe is sloped to it, the pipe slopes away. So if you lose power, you lose some of the biological control. There are some then that have these shallow drain fields after them. So you're basically pumping the treated effluent out to a shallower drain field, which is a little different than the deep leaching pools that we're used to. The goal of the shallow drain fields, though, is to get it up in the upper soil horizon, kind of like the rain garden idea. You use
Are those pumps working when the power's out?
No, that's the problem, is that those pumps will not run. But as we've gone through Hurricane Sandy and other, some natural disasters here, I think a lot of people are now equipping homes with generators or generator receptacles, and these pumps are not super energy heavy. It's equivalent to a couple of light bulbs. So if you had a generator, you could run it and your system would run fine. You wouldn't notice.
Don't some of the systems, though, from a no power perspective, don't they offer excess capacity to some degree, so you'd still be able to flush your toilet?
Yeah, again, some of these, they have, there is capacity in the tanks to allow, toilets to flush, sinks to run. But like Paul said, if you're in the middle of a power outage for a couple of hours, you're probably not going to be taking a shower because you don't have hot water. You're going to maybe only flush the toilet, and that's about it. Some cooking. You're not going to be running a full, your day-to-day life like you normally would, which these systems then can handle that for, that period of time.
Right.
So, Bryan, beyond the IA systems, and again, grander scale, what are we looking to do here on Long Island? What's really, like the 100% removal option for nitrogen?
Yeah, so I mean, for 100% removal, you're really looking at widespread county-wide sewage treatment and sewage collection. So that would be basically forming county sewer districts throughout the county, collecting sewage from pockets of homes. We're working on a project in Oakdale for right now, and we're looking at, just shy of 500 homes. Putting in a low-pressure sewer collection system, so collecting all the waste, pumping that waste to, this would be a connection to the Bergen Point facility. The county's also looking at other projects in, say, Forge River area and Mastic, where they're building a brand-new treatment plant and building the infrastructure and the collection system for the Mastic Shirley area to kind of pick that sewage up and move it to the new treatment plant. These treatment plants are again, in a league of their own. They're a step above IAs. They reduce nitrogen even further. They're down to well below 10, if not down to 3 or 4 on a municipal level. But, the downside to them is there's cost involved. We developed here in the county, I'll say, without that infrastructure in place 30 years ago. And that would have made things a lot easier. And now we're kind of having to go in and retrofit it.
So, I mean, obviously one of the big obstacles to sewering the county, parts of it are, but the rest of it, its cost has got to be, one of the toughest obstacles to overcome. What can we do about that?
Yeah, I mean, right now we're the county's floating some ideas. I mean, right now a lot of these projects have been funded on, New York State federal grants. There is a concept out there now with the county with creating a what they refer to it as a renewable income stream. So basically, potentially other areas, I think Maryland has done it, I think Massachusetts has done it, where in essence there's a fee associated with your water consumption. that gets used to, implement water quality improvement projects. We have, I think, some of the cheaper water rates that I'm aware of in the nation almost here in Suffolk County. And again, these projects in areas similar to ours where they've seen, groundwater and water quality and surface water quality degradation, that's the step you need to get to, is basically, having a fee that comes in that then gets spent on improving the overall water quality. And it seems like those programs have worked in these other areas. It may not be a popular concept, but it's something that I think without additional, you can't rely on grant funding for everything. So either, individual homeowners are going to have to take on the debt and pay it back, or the county's going to do it as part of a big capital project and everybody's going to pay for it, or there's ways with, this other fee to make it work.
So, obviously, I know the money isn't there right now to sewer the whole county, and we're looking at doing it more bite-sized pieces. And there's a prioritized list of areas, and you mentioned that watershed report, right? Mm-hmm. So, what's coming up? You mentioned Oakdale. Are there any other hot spots that that people are anxious to see sewers in, or?
Yeah, you're seeing it more, I'll say, on the downtowns areas, kind of like what Village of Patchogue did. They have sewers there, and you see that their downtown is, expanding and flourishing. And maybe not everybody wants to be Patchogue all over the place. But some of these downtowns, you go out to Southampton Village or East Hampton, or, go all the way out to Montauk. There's areas, Montauk especially has, poor soils. It's, 60, 70 feet of straight clay. You can't put septic in clay. It backs up immediately. And a lot of these places are kind of limited on what you can do because of the rules of, the sanitary rules. You're basically governed by your septic system as to what you can do. So you can't change an empty storefront from, one use into a restaurant or even into an office space without going through a wastewater management approval for your septic system. And sometimes that's not an easy thing to do. So you're seeing focus there for, community, sewage treatment and allowing for, I'll say, growth and recovery in those areas. So I think those are kind of like the key priority areas there as far as that goes.
No, I agree with you, but you look at the other side of the coin from the commercial, you go to the residential, and oftentimes, I talked about the cost obstacle. There's other obstacles that you may experience with, why do I need this? I've always had this out in my front yard. It works great, and how do you, educate people or convince them, that we do need to make this change? What's the key to getting through to people?
Yeah, that's a difficult one. I've been there, and I thought a couple times I was going to have tomatoes and pitchforks, waiting for me after giving those presentations a couple of times. Again, it as I said earlier, our old way of disposing of our wastewater was the greatest, set it and forget it scheme of all times. You put it in when you built the house. You never see the covers. You have no idea where it is. You just flush the toilet, it goes away. You don't even think twice. So again, it's starting to tell people, look, here's the downsides of this. You're starting to see, back in the 70s and 80s, you didn't have brown tides. You could walk across the bay on, clam boats. You had clams for days. Mm-hmm. You didn't have cyanobacteria in ponds. You could swim in these ponds that we were talking about before without even thinking twice about it. Now you're starting to see it. You have shellfish closure areas. You have beach closures. You have, there are no clams. There are times where, now we have fish kills, and you're starting to look and see those things. And those are tangible. People can see them. You can, go to the end of the road and see that the bay is brown. You can see that there's, dead fish washed up in a canal. And I think, kind of just showing people that that's what's happening. And if we kind of continue on the course, the draw for what brings people to the island and why people stay here and live here is going to be gone. There's going to be a day where, you're not going to be able to go fishing or clamming, or you're going to not be able to go in a water body for an extended period of time, without, running the risk of getting sick. And I think that's, ultimately when you don't want to get to that point. And I think we're not there yet, but if we didn't do anything, we'd be there pretty soon.
Oh, man, you made a good case right there, Brian. We're talking about water. We're not an island. It's surrounded by water, and it's a big reason of, why we choose to live here and recreate and, do what we do. So let me kind of wrap things up with this, take out your crystal ball. What do you predict? What do you think is going to happen? Are we going to make this change? 50 years from now, what's Long Island going to look like in terms of nitrogen, wastewater, the surface water issues, the groundwater issue? What do you think? Are we there?
We're there. We're making the change. The county, as of, I think, July 1st, is now going to require IA units on all new construction. And that's across the board. Residential, commercial. There's a few exceptions, but that was a big first step, and that took years to get them to that point. And talking to, the building trades and groups and getting everybody on the same page that, we can't just sit back anymore. But I think with that, you're going to see a big change. And yes, there's costs and there are downsides to it, but you're going to see a major shift there. And hopefully these big sewer projects, the county can get a couple of them off the ground and get them in the ground and show people again that, we can put this stuff in the ground and it's not going to be a disaster. It's going to go well. The project's going to come in, on budget, on time, and you can make it work where that people can kind of get behind it. I think that's the biggest thing is people have this misconception that it's a county project and it's going to go sideways on you. It's not. I mean, these are reliable systems. They've been used all over the world. You can kind of make this work, and we could become, I'll say, a poster child for how to do this right. Rather than kind of rushing to jump into it. But you want to show that we can do it and keep doing it. You don't want to just do one of these. If we do one sewer project, it's not going to change the tide. We need to do, the whole county. That's ultimately what you need to do to really make an impact.
Very lastly here, all right, any new technologies that'll make installing sewers or sewering parts of the county any easier, faster, cheaper? You mentioned the low-pressure sewer systems. That seems like to me a pretty good alternative, but it's also got its drawbacks as well as its benefits. I mean, what's out there?
Yeah, so for sewer work, there's your old school traditional gravity systems, which are, kind of like what you have in your house, but, we do that in the streets. The downside to those is you get down 20, 30 feet real quick, and then you need big pump stations to move stuff around. The low pressure sewers definitely are a good option. They have a grinder pump at your house, and then it, pushes that out into a collection system that consists of a bunch of smaller force mains that run in the street. There are effluent sewers, which are kind of a similar concept where there's a pump after a septic tank that just kind of the solids stay basically on your property and the liquids go out into the street and into the collection system. So that there's, multiple ways to kind of skin the cat, and there's various reasons why you use one system over another, depending upon your area and your, depth of the groundwater and things of that nature. But I think, once you get, people more familiar with the concept, and you could show them that it's not just a small isolated village like Patchogue that has low pressure sewers. They're the only one in the county that has widespread low pressure sewers right now. You want to show that these work, and we don't have to do everything the old gravity sewer way. The times have changed, and gravity sewer has its place, but it's not everywhere in Suffolk County.
So. We keep talking about Suffolk County, but Nassau County is predominantly sewered, correct?
Yeah, Nassau County, I think, is somewhere in the realm of like 95% sewered. There's a handful of pockets that aren't.
So would you say the water quality in Nassau County in regards to nitrogen is a little better off than it is in Suffolk?
It seems like it. You don't hear the same reports that you do on the east end of the island than you do on the west side.
So, just looking to the neighbor to the west, isn't that a good sales pitch for Suffolk County?
It is, and you can even look in the sound, the Long Island sound studies. And those have been going on for 20 years or so, and you can see improvements that have been made. Even just in the performance of the treatment plants. In Long Island and Connecticut that discharge into the sound. there were performance improvements made, and you can see that water quality is getting better. So kind of like you said, that's what you can show people, is that this does work. This isn't just a novel concept that you have to have a degree in biology or chemistry to understand. You can see it.
I'm with you, Brian. It's still a bit of an uphill climb, but I agree we're going to get there one day. Brian, I want to thank you for coming in today. Appreciate your time. It was very informative and educational on all different topics we covered on nitrogen and wastewater and how it relates to water quality issues here on Long Island, be they groundwater or surface water. I also want to thank our listeners today for joining us on this third part of a three-part series on water quality issues as they relate to Long Island. You can certainly reach out to us via pwgrocer.com for more information regarding any of the topics we've discussed. But definitely subscribe, to our podcast on all the different social media outlets, because we've got plenty more topics up and coming. Some of them may include topics like brownfields, the geothermal topics. Certainly going to be more environmental and water quality issues as we get into this. And we look forward to seeing and spending some time with everybody. Take care.